All right, so now we're getting into more advanced function work. Before, you would be asked a question such as f of 3. And let's say the function, I don't know, was something like negative x squared plus 2. That means in place of x, put a 3. In place of x, put a 3. Use parentheses so that you're going to be very careful. And that was not in the advanced function work. That was in an earlier module. And by the way, that's negative 9 plus 2. That makes negative 7. Okay. But now, and so just to be clear, you're given an x value, and you output a y value. Now, I'm going to ask you the opposite. Now, another word for f of x is y. We're now telling you the output, the y, is negative 11. And we want you to figure out what x is. Now, keep in mind, this is an equation. This, the earlier work, we were simplifying an expression. It was one-sided. We were shaping. We were doing PEMDAS. Now, we need to isolate x. We're solving. We're going to use SADMEP. So I've got negative 13 equals negative x squared. Divide by negative 1. 13 equals x squared, square root. X is plus or minus the square root of 13. Notice the difference in answers. Notice the difference in answers and in questions. Let's first look at the questions again. Here, you're given an input. You plug it in. Everywhere there's an x, aka an input, you plug in a value, and you see what comes out. That's old school. New school, you're given an output. You're given a y. So in place of y, only in one spot, you'll plug in that value. And you're going to actually solve. Here we were simplifying an expression. Here we are solving an equation for x. Notice how the answer is not just plus or minus the square root of 13. It's x equals. Why? Because the original question was an equation. So the answer is an equation as well, and it's a statement of the solutions. So that's really what's going on here. So here's a nice example. We are given that the output, as in y, is 5, so we substitute for y, aka f of x. And now we solve, and we know how to factor, and we can solve for that. So notice how we have two solutions because this was an equation. In place of f of x, we substituted in a 5, and we had to solve for x. We can have more than one answer, and our answer is an equation. It's x equals, unlike the previous function work that we did. So let's give it a whirl, shall we? Here we are told that h of x, aka y, is equal to negative 3. So we're not plugging in a negative 3 for x. Keep in mind, we were not told this. We were not told that x is negative 3. We were told that y was negative 3. And then you can solve this quite easily. Add 1 to both sides. Divide by 4. Simplify. X is negative 1/2. Your answer is an equation. You found that there just happened to be one solution. By the way, what that means, please don't write this in your answer, but this is what it means. We found out that when y was negative 3, it turns out x is negative 1/2. That's what we did. We just found that point. But that's not the answer, so please don't write your answer that way. Your answer is an equation. The solution or solutions is or are, boom. Then you just say what you solve for, what you found. Okay. Again, we are given what k of x equals. You have to be able to differentiate this. You got to be really careful. Okay. We know that y is 4. In place of y, we substitute that in. Oh, and now we have an absolute value. Now we're reviewing Module 1. We'll peel off the absolute value bars and set it equal to 4, as well as the opposite of 4. Add 3. Add 3. Divide by 2. Divide by 2. Answers. X equals 7 halves and -1/2. Those are our solutions. Notice how the answers are not just 7 halves and -1/2. It's x equals. They need to be equations. You need to state the solutions because you are asked to solve an equation. Here we are again, given y. In place of f of x, aka y, we'll put a 5 there. Oh, and this is a quadratic. This is a nice review of earlier modules. Now, hint, we're going to have to probably use the quadratic formula here. They want to know all solutions. They want us to find all x. What we're going to do with our quadratic formula here. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. That's x equals 10 plus or minus the square root of -10 squared is 100. -4 times 1 is -4. That's going to be 92. So that's 192 divided by 2. I'm going to go to the next slide. 10 plus or minus the square root of 192 over 2. X equals 10 plus or minus the square root of 192 over 2. We should clean this up. 192, I believe that 4 is going to go into that. 4 times 4 is 16. 4 times 48. All right, so I think, 16. If 4 goes into it, maybe 4 squared goes into it. 16 times 1 is 16. 16 and 12. Ooh, wait. We could even go bigger. There's another 4 that goes in there. This is going to be 64 times 3. Wow. We can really simplify this now. 10 plus or minus the square root of 64 times 3. So x equals 10 plus or minus 8 root 3 over 2. Let's keep simplifying. We're going to put each numerator over the denominator. 10 divided by 2 is 5. 8 divided by 2 is 4. And that's not our answer until you say x equals 5 plus or minus 4 root 3. Those are our solutions.